Okay, let's take a look at some piecewise linear absolute value functions. So let's go for y equals x plus 2 with absolute values around it. So last year we saw y equals mx plus b. This looks familiar. Now let's graph the absolute value function. So remembering, we were going to do a positive case and a negative case. So y equals positive x plus 2 and y equals negative x plus 2. So now let's do it with the table of values. So x and y. Now we're going to take the x values, negative 5. I'm just going to pick them for reasons, and then you'll see why, and then you'll know what to do later. Negative 3, negative 2, negative 1, 0. So now I'm going to take the first x value of negative 5 and put it in, so we get y equals the absolute value of x plus 2. Always writing my formula, vertical bar, absolute value. And then substituting in the formula. So y equals the first value of x in the formula is negative 5, putting negative 5 in, negative 5 plus 2. And then y equals absolute value, negative 5 plus 2 is negative 3. And the absolute value of negative 3 is positive 3. And we can put that in the table, positive 3, and we can put that point on a graph. Well, I'm going to find a couple more points before I do that. Yeah, why not? Okay. So now, remember, let's try and do them in our heads like we learned back in grade 8 and grade 10. So I'm going to put an arrow from the x value in the table just to the formula, just to remind. So we're going to take negative 3, we're going to put it in for x. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is positive 1. Now taking the next value in the table, negative 2, and putting it into the formula, y equals the absolute value of x plus 2. Negative 2 plus 2 is 0. The absolute value of 0 is 0. Therefore, we have the point negative 2, 0. Putting negative 1 in, negative 1 plus 2 is 1. Absolute value of 1 is 1. And putting in 0, 0 plus 2 is 2. Absolute value of 2 is 2. Okay, look at this. We're getting all these positive y values. Obviously, it's the absolute value. Unless it's shifted up or down, we'll get positive y values. So let's go for a positive graph. Ooh, x was too far. I got to move my y-axis over. Excuse me. So we have negative 5, 1, 2, 3, 4, 5, 1, 2, 3. We have negative 3, 1, and 1, 2, 3, 1. Negative 2, 0. And 0, negative 1, 1, and 0, 2. So we have a V shape. A new absolute value function. A V shape. And it turns out that the positive case is the one on the right in this case, and the negative case is the one on the left in this case. So writing the formulas of the equations near where they are, y equals x plus 2 from grade 10, and doing the negative case, these have crisscrossed, Doing the negative case, y equals distributing in a negative into the brackets, negative x minus 2. And if I were to extend that line, you could see that it would have a y-intercept of negative 2, and it has a slope of negative 1 over 1. And for that matter, the positive case could also continue on. And that's going to be a great way to be able to graph it in the future. So, notice the English instructions down below. The graph of the absolute value of x plus 2, the V, is the graph of y equals x plus 2 from grade 10, the positive case, and y equals negative x minus 2, the negative case, without any negative y values. And we get our V shape. And this can be written as, you are looking at your notes that you've printed off, a piecewise function, where we just say y equals x plus 2 and negative x minus 2, the positive case and negative case, and then we just give the domain. And you can either find the domain from the graph of the positive case and the negative case, or do the method down below. The domain of the positive case is setting what's inside the absolute value greater than or equal to 0, and the domain of the negative case is set what's inside the absolute value less than 0. Notice less than does not include. Big blue, less than does not include. Okay, so that's graphing absolute values. So we've taken a look at absolute value equations and now absolute value graphs called piecewise functions because they are pieces of functions, like this new V shape. So now we've seen a line. Last year we just saw a parabola, and now we've seen a V. Okay.